Hi class, I am going to cover some portions of Lab 8 to help you understand this lab better. I went through it and I did not like that a lot of information was omitted from this. So I put together some slides to help you navigate through it a little easier. The objective, every assignment you were given, basically in reading or in labs, you have an objective. The objective breaks down what you are supposed to learn from that assignment. I went through the reading and basically this assignment you are going to be given a certain amount of copper and you're going to go through multiple reactions. If you look at this last part, you're given copper wire. You're going to go through multiple reactions, and I will let you know as being worked in the lab, the more reactions you go through, the chances increase that you're going to have a smaller and smaller yield by the time you're done. So in this case, you're going to go through multiple reactions and end up with a certain amount of copper at the end, which is what you're trying to recover. To break this down as simple as possible, you are going to start with an initial mass of copper and you're going to have an end mass of copper. And ideally, what you want to do is match the initial mass with the end result mass that you recovered. And through percent yield, you will be able to determine what that amount, if it's a good amount or not. There are 3 reactions that are covered in this. I'm not going to go too much into detail, but you will see these written out, so that's the only reason why I'm discussing it, but your reading really doesn't point or explain what they are, because this is an understanding you come with this information from Chem 10, but I felt that they should have explained it a little better. So redox reactions has to do with the loss of electron or a gain of electron, and when that happens, the oxidation number either increases or decreases. I'm not going to go into too much detail because nothing in this lab really talks about redox reactions except for the fact that the reaction you're looking at is a redox. But I have supplied another slide to give you more information if you felt that you wanted to start looking at this. We will be looking at these, but not at this moment. A metathesis reaction is a reaction that means to transpose. These are double displacement or double replacement reactions. So if they look familiar from this bottom of this AB plus CD, that's what they are. They produce stable products that either are a precipitate, which is an insoluble solid, or a gas. And how do you know you have a gas? Because you see bubbling. When you no longer see bubbling, then that means the gas is gone. This would be a perfect example of soda. When the soda is flat, the carbonation is gone, the CO2 has left. The third reaction is a decomposition reaction, which exactly it means you can break it down from the word. It decomposes. In this case, you start with the reactant and it breaks down into multiple products. And you can see here, we have it in the general form, an example with a compound that decomposes and a turtle. So this should give you an idea of what happens here. You have more products than you do have of a reactant. For some strange reason, you might be asked 1 or 2 questions, and they refer to this as dehydration. So if you're wondering where that came from, that's what they're insinuating on this type of reaction. Reactions for this lab, this is also listed in your PDF. These are very important. These are the steps of this lab. You need to fully understand the procedures and read them and make notes if you need to, because there are several questions asked about in steps of what's going on, and it would be really easy to lose concentration on what's happening here or not be able to put the thought process together to figure this out. So you should print this lab out or make notes or keep this close by. And this is they tell you here, they have the equations listed with the 4.1, all the way down to 4.5. They have the type of reaction and they have the complete and balanced reactions for you. Now there are multiple steps in these procedures, so think of this just as a summary, not the whole thing. There are other things that happen and are explained in the procedure. The final thing is to get the percent yield. A percent is out of 100. So if you end up producing something that's close to 100, that's great. If you have a lower amount, then that might not be so good, and there might be multiple errors that were conducted during this process. Now, in your book, in the PDF, it refers to at the bottom as recovered mass of copper, so that would be the end amount, and the initial mass would go on the bottom, and the grams would cancel out. I forgot to put grams here. and that would give you a percent recovery. This is out of 100, so you would have an idea of where that the percent stands. Normally, if this looks familiar, it's because you learned it around the same chapter of limiting reactants. The actual yield is the amount that is conducted in a lab. And the theoretical yield is the amount that you would calculate on paper with a balanced equation. And the theoretical is exactly that. It's in theory. It's the max amount of product that could be produced without any complications, problems, or errors. In reality, nobody ever hits the theoretical amount when you do actual yield because errors and everything else just happen. Here's a practice problem that was given to you in the PDF. It gives you the answer. It gives you a brief summary of how to solve this, but doesn't give you the breakdown, and I don't like that. So I'm going to break this down for you. If 3.35 grams of copper 2 nitrate are obtained from allowing 2.25 grams of copper to react with excess nitric acid, what is the percent yield? So what is the full amount that was recovered from this reaction? How do you do this reaction in the first place? Well, you have to make a complete balanced equation. They do not provide this for you. They expect you to do it, and at this level of chemistry, it may take time, but yes, you should be able to put a balanced equation together with the physical states. From there, you would determine the theoretical yield. If you are getting lost on this, you need to go back to limiting reactants, find theoretical yield, and read up on this. The theoretical yield is the value that would be determined on paper, so I've given you an idea of what we need to do. So if we are given the actual, and the actual is the 3.35, we have to determine the theoretical. I have actually completed the balanced equation for you, and what I normally do, and I still do it, is exactly what you see here. I pull the mass amounts that are given to me for an equation, and I put them directly under that compound so that I can see what I have and what I need. In this case, we only care about what's involved with copper. The nitric acid is an excess. I could write excess underneath it, but we don't need it. And the hydrogen gas that's emitted, involved, we don't need that either. So what do we need to do here? Well, I just stated that the 3.535 is the actual, and we can start with 2.25. So in order to do a theoretical, we need to carry this through with stoichiometry to determine what the max amount of our product would be on paper in perfect conditions. So here we go. I set it up. I have the molar mass. This should be somewhat familiar. And if it's not, you definitely need to go back, or you need to start coming to my meetings that I have with students and looking at the problem set. So these steps should be pretty self-explanatory how I got to this. This 6.64, this is my theoretical. So if I had done perfect in a lab setting with no problems, the max amount that I can produce is 6.64. In reality, it never happens. So I pulled this from another slide. You can see we have the actual yield and the theoretical yield. And here again is the problem, but it looks like the Windows PowerPoint messed it up a little bit. But you can refer to it back right here. It's nice and clean. So 3.35 grams is the actual yield. 6.64 is a theoretical. These should never be reversed. You can't make something out of nothing. You guys are learning the laws, and you should know that. You'll never get more out of the actual than what is on the theoretical. So that should also, in a sense, help you most of the time if you did these right. The actual will always be lower, or should be lower, than the theoretical. So I set it up. The percent yield, 6.64 is on the bottom. That's the theoretical. 3.35 grams is on top. Times it by 100. I carried it out. But this is 3 sig figs. This is 3 sig figs. And we remember the multiplication and division rules. We have 50.5, which is the answer that was given to us. So if you are having problems with this, definitely look these slides over with the practice problem. Percent yield is always out of 100. So if you end up getting something, and this happens in my lab in person all the time, what happens if you get an amount that's over 100 or really low? I have gave you a list of what could happen here. Reactions are not carried to completion. Impurities will cause the yield to go up because they have not left. You did not clean them away. They are still attached. And that happens within lab a lot. When students want to get out and they don't want to carry things to completion. Improper measurements or calculations. Depending on what you do, this is kind of on its own. I can't give more explanation to this because people transpose numbers. They don't wait properly for balances to tare. Just a lot of things here. So this can go up or down. Not waiting for glassware or the product to dry completely. In this lab, things will be heated or steamed. You have to wait for these items to become to room temperature. If they don't, heat's still leaving. That means that the heat is still attached and it's going to be a larger amount than what it normally would be. That means that the yield will be more because the full amount of heat has not left the compound and or glassware. Decanting incorrectly, loss of copper. So it will result in the yield being lower. Why? Because you're losing the copper. Because you're losing the copper is gone. So in the end, the yield is going to be lower. And now tips to help you. I've taken a picture of the procedure and there are bracketed numbers here. You need to pay attention to these bracketed numbers because when you look at the report sheet, they are bracketed. So these bracketed numbers match the procedure and what is being asked at that point. So this would be very good to break this down and write this out if you needed to understand exactly what's happening here. And some of these questions are complicated. But at this point, you guys should have the knowledge to be able to pull this out. It just may take some effort. When completing the report sheet, read through all the areas you do not need to complete. What do I mean by that? There's areas that you're going to enter information in, and then there's areas that are already given to you. So it would be in your best interest to read all those areas that you did not have to complete. Because here's a hint. You're going to have to answer some of those questions that are based on that. So don't make things harder on yourself or wondering where that information is. They gave you the information. This will just take a long time to understand if you're not taking really good notes. So I would suggest with every step, make notes so that you can easily refer back to it if you have to for questions. This is a lab that is not complicated. It really is not, but it demands effort and concentration and to be organized in order to answer these questions. I hope these slides help you. And for some labs like this, I will step in and make slides. For others, I will not. So this is not going to be a weekly thing. You can always email me or post a question about it. However, if you wait on my answer and it's a Friday at 11:30, you're probably going to get a 0 on that lab because I'm not online at that time and I shouldn't be. So if you feel that you may have problems on these labs, it is in your best interest to start them as early as possible and to give me time to respond because I will not give anybody credit for sending me an email asking for help without giving me time to respond. Okay, so students, hopefully this helps you, and we're going to end this message, this now.